This is Bill Howard, and I'm making this recording in December 2011. Jim Logan, the Logan Surname Administrator, kindly sent me over 100 Logan Y-DNA haplotypes, and I have entered them into a program that produces a time-calibrated phylogenetic tree. We can also produce an RCC matrix of numbers that indicates time-calibrated relationships between any two pairs of haplotypes. An analysis of the surname clusters you will see here is virtually identical to the groupings of families on a pedigree chart. This shows that pedigree lines can be predicted from DNA results, and DNA results can suggest pedigree lines. Although individual pedigree lines seldom go back farther than a few to several hundred years, DNA can estimate where those pedigree lines will converge to a common ancestor much further back in time. The clusters of these haplotypes are apparent, and they are shown as boxes in the matrix. The major clusters are colored at the upper right of the cluster. Haplotype pairs within each cluster are not only closely related, but every testee in the cluster will have a most recent common ancestor who lived within a genealogically interesting time period. We can also see these results on a phylogenetic tree that we will show near the end of this presentation. We begin at a date when the average testee was born, presumed to be about 1945. At that date, RCC is set to 0, and our timescale is set to 0. In each matrix presentation, we list kit numbers of the testees down the left side of the matrix, and they are listed in the same order across the top. The intersections of the matrix give the RCC value of the time relationship between each pair of testees. Higher values of RCC indicate older times. At the beginning, 0 years ago, there are few exact haplotype matches. As our presentation goes back in time, we will see more detail as the surname clusters in the boxes begin to fill up. Now we will see what happens when we go back 50 years. We see very little change in the matrix. The first time there is a significant change in cluster composition is found on the next time slice, 100 years ago. This is well within the genealogical timescale, and most of the testees who were paired at an RCC value of less than 3 could easily know of each other's line by comparing pedigrees. As we move to 200 years ago, to the middle of the 18th century, most of the clusters appear to be at least half filled. We are now about a quarter of the way back to that point in time when surnames were adopted in Europe. Now we go back to 400 years ago, near the time of Henry VIII. We are about halfway to the time when surnames were adopted. The colored surname clusters are mostly complete, but no intercluster values have yet shown up. When that happens, a testee from one cluster is paired with a testee from another cluster, and as the intercluster region fills up, we will get indications of the time to their most recent intercluster ancestor. When we get to 800 years ago, we are nearing the time when surnames began. This was just before the Plantagenet kings reigned in England. Even the peripheries of the cluster insides are now filled, but as yet no intercluster pairs have appeared. We note that we are nearing the boundary between genealogic and genetic timescales. At 1,000 years ago, in the middle of the 10th century, we begin to see hints of activity in the intercluster region, but nothing of substance has yet appeared. We are now at about the time when other surnames begin to show intercluster activity at values of RCC between 20 and 25. Activity in the intercluster regions began to pick up 1,200 years ago in the middle of the 8th century, just before the first invasion of the Vikings. We note that the haplotypes of this group of Logans belong to haplogroup R1. They do not belong to the I haplogroup typical of the Vikings. We begin to see faint connections between the orange and the yellow cluster, and between some of the colored and smaller clusters, but nothing more. At about RCC 35, at the middle of the 5th century, 1500 years ago, the Romans had already left Britain. Increased activity is seen in the intercluster regions between orange and yellow and between pink and yellow. Similar activity is seen between members of the smaller green and light blue clusters. The dark blue and purple clusters at the bottom right are showing intercluster activity. When we go to 1750 years ago at RCC 40, at the end of the 2nd century, we are in an era when the Romans had just conquered Scotland. The orange-yellow intercluster region is nearly filled, indicating the time to their intercluster ancestor was about 200 AD. Similarly, the green and the light blue clusters now have a well-developed intercluster region, but the pink-yellow intercluster is only about 1/4 filled. The dark blue cluster and the orange cluster intersection is now almost full. The purple cluster in the lower right has no intercluster connections with any of the other clusters, except for its partial overlap with the dark blue cluster. 2,000 years ago at RCC 46, around 55 BC, Julius Caesar invaded Britain. The RCC matrix now shows good intercluster relationships between most of the colored clusters, but the purple cluster at the lower right still has no significant intercluster connections, indicating a greater age for the common ancestor between that cluster and the others. At 555 BC, around 2,500 years ago, the Iron Age had begun, and the Celtic people were about to arrive from Central Europe. Finally, the older purple cluster begins to have intercluster connections with the other clusters, but its connection with the orange cluster was the most complete. At 1055 BC, 3,000 years ago, trade routes and small villages had formed in Britain. The pink, orange, and yellow clusters had fully populated interclusters, and the green and light blue intersection is fully formed, as is the orange-purple intercluster region. The purple-yellow connection is over 50% full, but the purple connection with pink, green, and light blue had not begun. 1,000 years before this, at 2055 BC, or at RCC 92, the Bronze Age had begun, and Stonehenge was nearing completion. All intercluster connections had filled, except for those between purple and 3 other colored clusters, pink, green, and light blue. Finally, in 3055 BC, just before the new Stone Age began, and about 3,500 years after the land bridge joining Britain to Europe became flooded, making Britain an island, virtually all the surname intercluster areas were filled. So, by 3055 BC, all the haplogroups in this surname sample have been connected with their common ancestor and intercluster ancestors. Now let us look at the phylogenetic tree that was generated by Mathematica using the same set of Logan haplotypes. The tree is large, and we identify only the regions of the tree where 5 of the major colored clusters are located. The pink cluster appears on another page off the bottom of the chart. The number of testes in each color-coded cluster is given, and they are virtually identical to the colored clusters we have just seen in the sequence of time-sliced matrices. We also must emphasize here that these clusters on the tree and the identical clusters in the RCC matrix can all be traced to specific pedigree lines for each testee that often go back many generations. The vertical column to the right, where the kit numbers are listed, is placed at the starting year 1945, where RCC equals 0. Time in the past is off to the left, where the dotted vertical lines indicate the values of RCC at intervals of 50, or about 2,160 years. You can see that the most recent common ancestor of a colored cluster generally appears below RCC 20, or 860 years ago. Many are located below RCC 10. If you follow the junction points back in time, you can see estimates of when the common ancestors of pairs, groups, and clusters of surnames lived. A 1 standard deviation error in these determinations is estimated to be about 8 to 15%. At the top of the tree, you can see kit number 57207. This testee is an anomaly who probably does not belong to the other families on the tree. He does not share an ancestor with these other haplotypes until about RCC 235, over 10,000 years ago. He is probably more closely related to other family surnames. Let's look at the green and light blue clusters to see how they appear to be connected in time. The 7 members of the green cluster have a most recent common ancestor at about RCC 11. They share a most recent common ancestor with kit number 60820 outside that cluster at about RCC 38. Just below the green cluster, the more loosely defined most recent common ancestor of the light blue cluster lived at RCC of 7 or 19, depending upon how you define the cluster membership. But it is evident that the progenitor whose line split to form the green and light blue clusters lived at about RCC 42. This is about 1800 years ago, or AD 126. We can extend this analysis of the junction points of clusters, recognizing that Mathematica optimizes the position of every haplotype on the tree. In the table, we list the junction points where each colored cluster shares the most recent common ancestor with the other colored clusters. Above the diagonal, we show the RCC of the junction point, and below the diagonal, we show the dates in the past when that most recent common ancestor, the progenitor of the members of the cluster pair, lived. Note that mutations will cause errors in these dates, but again we estimate that they should be good to about 8 to 15%. The junction points on the phylogenetic tree show, in another way, what we saw in the evolution of the RCC matrix. That is, the oldest cluster is the purple one and the youngest cluster is the green one. In this presentation, we have used 37 marker Y-DNA surname haplotypes to generate both an interactive RCC time slice matrix and a phylogenetic tree. Studies of the junction points on the tree give us estimates of the time when the members of a cluster share a most recent common ancestor, and when the common ancestor shared by any 2 clusters lived. Once we have any set of haplotypes, we can see from the phylogenetic tree how the evolution takes place as mutations produce the junction points on the tree down from the progenitor to the set of haplotypes of current testees that we see today. The RCC timescale, where 10 RCC is about 433 years, was calibrated using over 100 pedigrees where the birth dates of the entries were known. This RCC correlation approach to analyzing haplotype strings has been published in the refereed Journal of Genetic Genealogy, and at the same time of this writing, 4 other papers are in press.